The human cost of the Gulf War is not in dispute. More than 100,000 people were killed, the majority of which were Iraqi soldiers. It'll take years to clear the desert of junk and unexploded bombs. The war ended in February 1991, but it wasn't until November 91 that the last of the hundreds of oil fires was extinguished. While they burned, the fires released poisonous gases into the atmosphere.
In January 1991, Saddam threatens that he will destroy all the oil wells in Kuwait. By 14th of February, he managed to destroy and damage 730 oil wells.
Many people thought that the damage would cause an environmental catastrophe on a global scale.
To produce a plume of smoke that could cover Bombay, it would probably get around the world in a month.
Qui détruisent actuellement les installations pétrolières au Koweït.
إن آبار النفط المشتعلة في الكويت zum größten Teil in Flammen stehen sollen.
There would be a catastrophe such as Mother Earth has never witnessed.
Kuwaiti officials estimated as many as 6 million barrels of oil a day were going up in smoke. No one really had the experience to tackle so many fires burning so close together. Firefighters from around the world descended on Kuwait in an attempt to extinguish the fires as quickly as possible. Getting the water and the equipment to the burning oil fields proved to be a monumental task. Even when that was done, they had to take some drastic measures.
We're planning on shooting the well out with dynamite because yesterday we uncovered the coke off of it, and it has no valves on the casing or the tubing. And so we have 3 fires, one going out each side and one up at the top. We tried to put it out with water yesterday afternoon, and we just couldn't get it out with water because it's spread out a little bit. And we're planning to shoot it out with dynamite this morning. We got a 55-gallon drum on the back of our boom, and we'll back it up there, and we'll make a dummy run, get everything all spaced out, and then we'll bring it out.
Standing near the fires made the rest of the sweltering hot desert feel like a cool breeze.
Don't get no hurry.
We packed explosives in it. The second time we go in, we'll shoot the thing. What that does, the explosive knocks concussion from the explosion knocks the oxygen away. And if you got water on it and got it cooled at that time, well, the fire will stay out. Immediately after the fire's put out, we hope to continue pumping water on the location to keep it cool, to keep reignition happening. And if we've got it cool enough, it will not reignite. After about an hour cooling it down, we'll cut the water off, and then we'll go to work on the wellhead.
Once the fires are out, they have to stop the flow of oil.
The biggest problem we're going to have is if the well reignites, and it can reignite from any spark, from any source. Swinging over top, the wellhead nicks the wellhead, we've got a spark, we've got a fire again. And then I've got 3 or 4 men in there that I've got to get out of there.
It's a real rush. It's awesome. I don't know. It's just really neat. Heart's going 100 miles an hour.
The last oil fire was put out on November 6, 1991, but the damage to the environment is now in dispute.
Well, apart from the 100,000 or 200,000 people killed directly in the war, the environmental consequences have been extremely severe. In fact, it's fair to call it an environmental catastrophe. The most dramatic environmental effects have come from the burning oil fires, which pumped huge quantities of pollutants into the atmosphere, particularly sulfur dioxide, and some 1 million tons or so of sulfur dioxide have come down in the form of acid rain, which have acidified the soil and the water supplies in the region. So all in all, it really is an environmental disaster. It has wrecked Kuwait, and it will be decades before Kuwait and the region fully recover from the environmental damage.
The levels of pollution we found in the middle of the smoke plume, just downwind of Kuwait, were not really that much greater than you would expect to find in the worst cases of pollution in major European or North American cities. The exception to that is, of course, the actual black smoke itself, which was very thick. But things like sulfur, nitrogen oxides, ozone, and so on were not much greater than we've seen, certainly in England.
I don't think there's any question at all that the amount of sulfur dioxide that went into the atmosphere from the Kuwaiti oil fires is substantially greater than any other comparable populated area has experienced. In relation to nitrogen oxides, something similar can be said, and in relation to carbon and soot, over a period of 9 months, that is greater than any industrial city anywhere in the world has ever experienced.
I think one of the wrong things that the various scientific groups and missions who came to Kuwait, that they are dealing with this situation and this environmental catastrophe as they are dealing with a problem in an industrial factory or emissions from an industrial factory. They are looking for pollutants such as nitrogen oxide, sulfur oxide, CO, CO2, and H2S. However, in this situation, although we are having an emission of these pollutants, we should look for more dangerous pollutants such as volatile organic compounds, inorganic acids, heavy metals, and polycyclic aromatic hydrocarbons.
The first lesson of the Gulf War is that modern war is enormously destructive of the environment. The second lesson is that scientists are not good at predicting the environmental costs of war unless they're given adequate data, and this indicates the need for an international data bank which will give them the data they need to predict those costs. And the third thing is that governments have been very secretive about the human and environmental costs of the war. They've been secret about the human cost because they're embarrassed about the large difference between the number of casualties on the Iraqi side and the relatively small number of casualties on the coalition side. They're secretive about the environmental costs because they don't want people to think that those costs are so huge that the war wasn't worth it.
All fires can be extinguished by applying some simple scientific ideas.
You have three things. You have the heat, you have the source, and you have the oxygen. You eliminate one of those three and you can put a fire out.
Scientifically, it's very easy. Take away any one of these three ingredients and the fire goes out. But in practice, how do you stop the fuel from gushing out of a blown-up oil well? The obvious way is to block it off. These trucks are carrying a type of chemical mud which has to be pumped down the well.
Here we have some of the stingers that are used. The stinging method involves poking one of these mandrels down into the well so that you can pump mud into the well. The mud will overcome the pressure of the well, and when you get enough mud in the well, then the well is dead. This goes on to an end of a boom called an 80 wagon boom. And it's a long extension that will carry the pipe that carries the mud down to the stinger that goes into the well. So the 80 wagon has got a lot of weight. The end of this wagon has got enough weight to hold down the stinger to make sure that it stays in place once it enters the well.
With the well blocked, the fuel side of the fire triangle has been broken and the fire extinguished. But some fires can't be blocked off in this way. So what are the other options? The heat from the fire can be removed, breaking the fire triangle in a different place, and that's often done with water.
We're going to be using the water first of all, and that'll just essentially cool the oil. At the combustion point, you can just see a small area where the oil is leaving the wellbore, and there's a couple of feet there before it starts to burn. Now at that area where it starts to burn, the combustion area, if we start at that point with our water, it will cool the oil and we should be able to chase it right up, thus extinguishing the fire.
The third way of breaking the fire triangle is to remove the oxygen from the fire. Explosives use up all the oxygen around the fire, and that does the job. Alternatively, a dry powder can be used to smother the flames.
And we'll bring the dry chemical in with the cat, and which we'll set approximately about 8 feet away from the well, and the dry chemical will extinguish onto the fire. Which the dry chemical will do is take away the oxygen and snuff it out. It will just automatically put her out, hopefully.
In this case, they're using dry powder and water, tackling the fire triangle from two sides. Fires need oxygen. The more oxygen, the faster they burn. With liquid oxygen, they burn faster still. This biscuit is soaked in liquid oxygen. A piece of wood burns so well when it's soaked in liquid oxygen that it even burns underwater. But what happens if you can't increase the amount of oxygen? Aluminium foil won't burn, but if you grind it into a fine powder and blow it into a flame, it will. Lumpy custard? Powdered custard? Most substances like hydrogen in this jar, need a flame to burn. Or do they? This is platinum, used as a catalyst. This can is filled with natural gas. As the gas burns off at the top, it's replaced by air coming in through the bottom, which mixes with the rest of the gas. Gas leaks at home are devastating when the proportion of air to gas reaches a critical point. There's a leaking cylinder of gas in this van, and there's a spark. Phosphorus has to be cut underwater, because if it's left in the air, it catches fire on its own. All burning reactions are examples of oxidation, because the substance that's burnt is oxidized. Burning substances are chemically combining with oxygen. The oxygen is an oxidizing agent. But the oxidizing agent doesn't always have to be oxygen gas. Potassium chlorate is a strong oxidizing agent. It's got lots of oxygen in it. You'll see the point of the coin later. The white substance is the potassium chlorate. Phosphorus dissolved in a liquid is added. When it's touched with a hot metal rod, during the flash, the phosphorus was oxidized by the potassium chlorate. The reaction was so ferocious, it was as if the metal plate had been hit by a sledgehammer. Reactive metals like magnesium can even burn in carbon dioxide, a gas which normally puts out fires. The magnesium combines with oxygen in carbon dioxide, coating the jar with magnesium oxide powder. The black specks at the bottom are carbon. But can things burn without any oxygen? This is sodium metal. It burns in air. But here, it's burning in chlorine gas. So if there's no oxygen, how has the sodium been oxidized? Sodium metal is made up of sodium atoms. Each atom has one electron in its outer shell. When sodium burns in chlorine, each sodium atom gives its outer electron to a chlorine atom. The same thing happens when sodium burns in oxygen. The outer electron is given to an oxygen atom. So more accurately, when something is oxidized, it loses electrons. Oxidation is loss of electrons.